start by just introducing myself if you haven't participated in any of our webinars already. My name is Claire Gandy. I'm your sales director for the corporate office, handling Europe and North America. I am going to jump right in here. Unfortunately, due to the nature of this type of session, we won't have time for a live Q&A. But if you do have any questions over the course of our session today, please do send them in the form of the question or chat feature, and I will respond to each of those directly after the closing of the session today. All right, so talking today about this Builder software and the integrated column design, let me talk for just a moment about what Builder is. Builder is a 3D finite element solution for multi-story concrete structures. So it includes detailed PT and RC slab design. We have a patented tributary load takedown feature with an integrated column design option, which I'll be showing you today. We also have a new wall design feature that'll be available in the upcoming 2017 release that's coming up in about a month, with additional component design options and improvements to come down the line. But primarily today, these are the components we'll be working with, is the column design using both the tributary load feature as well as the finite element analysis. So Builder comprises of several components. So in the center you can see this kind of overall building architecture. So there are several components playing into the design of a structure. From an analytical perspective, the top left image is showing you Adapt Edge. This is our multi-level gravity and lateral analysis solution. This is what allows you to do the tributary load takedown, the FEM analysis, lateral analysis for both wind and static seismic loads. And this is the way that we're allowed to, or not we're allowed to, that we're enabled to do integrated column and wall design as they relate to multi-level modeling. Obviously, that's how those make sense. The elevated floor designs is going to be in the module called Adapt Floor Pro. This is for both PT and RC floors. And Adapt and Mat is for the design of foundation. So, you know, you do your multi-level analysis in Edge, and then you can automate the load transfer to your foundation and design that via Mat. But outside of the scope of this seminar today, Mat and Floor Pro are covered in other demonstrations that we do. Today we're really just going to be focusing on Adapt Edge and the column design. So what's available when it comes to column design is something that's unique to our solution. Because we have a patented tributary analysis option, you can design your columns for one of four force sources. I'm just showing you a quick screenshot here. This is something that we'll review in the software in just a moment, but I wanted to highlight this because this is such a unique feature that we offer, that you can design your columns for the tributary method only, or the finite element solution, or an envelope. Typically what we found is that our clients are doing usually a tributary calculation offline, let's say outside of their software. They're doing it maybe in Excel, and then either using that to design their vertical elements, or just using it as a back check, but not as much of an integrated approach that considers both the FEM and the tributary. And so that's something that we uniquely offer here. And again, this is something I'll go into more detail in the software. The tributary method is something that's really kind of important, because we found that the vast majority of engineers at least do some form of calculations, usually hand calculations using Excel, to calculate these tributary type loads. And what the program does is it calculates very, very quickly and effectively the geometric tributary boundaries of your floor system, and as well transfer conditions are identified, and the load path is very clearly shown and it's something that you can control. So if it's a two-way flat slab system that's transferring, you have control to manipulate where that load path is going. And this is not limited to only simple structures. As you can see here, this is a fairly complex floor plate, and this is very easily handled by our tributary loading algorithm. It does not require any kind of FEM mesh or analysis to be completed, and in fact that's one of the benefits, is that you can do a tributary analysis before you have a finite element mesh or solution, so it's much faster and more forgiving. It can also be more correct. So let's just use this as a quick example. In a scenario like this where you have this gray shape just kind of indicating some other, portion of your structure. If you have this kind of transferring condition in the tributary method, the column here is going to receive half of the load from this floor and half of the load from this floor or roof, and all of that will be considered in this, this loading that you're capturing here. However, from a finite element solution perspective, because of the stiffness of the structure, the way that the model is put together in this case will actually underestimate the value of loads in this column here. So there are times when it is conservative to use the FEM solution. There are times when it's conservative to use the tributary method, and that is why we offer the automatic envelope that you can choose to capture the worst case scenario. And when you do have both of those solutions in your model, you're able to very quickly identify not only what the two solutions are, but also how they compare. So you're able to see for any given column what the tributary results are. So for example, on this particular column here, the single level tributary loads being 38 kips, the cumulative self-weight 266 compared to the cumulative FEM self-weight of 170 kips. So in this particular example happens to be a 56% difference, almost 100 kip difference in the favor of the FEM solution being unconservative. So it's just a single example of this kind of instance, and the program has flagged this text in pink to show you that it's exceeded some default filter, which again I'll show you. So with that, I'm going to hop out of PowerPoint and jump into the software itself. So I'm going to just start with a quick and easy model. This is a model that I've literally just imported from Revit and added a few gravity loads to the slab, just something very simple. And from here, what I'd like to do is just simply calculate the tributary loads, showing you this methodology within the software. So to do that, I'm going to bring up the tributary loading feature and generate tributaries. So you see that this has now brought up these red kind of lines, these boundaries on each floor slab. I'm going to then calculate loads, and that will calculate all of the loads on each floor and each each column and wall element. This also highlights and identifies any transferred columns or walls. It's really outside of what I wanted to discuss today, but I did just want to mention that that is brought up for you very easily. So now we've established our tributary loads, we can take a quick look at seeing maybe what some of these loads look like. So for example, here on a single level, I can see the tributary boundary, the area and loads for any given column, for example, as well as the cumulative forces. So from a cumulative standpoint, we're looking at self-weight of 567 kips, whereas from a single level tributary standpoint, we've got only 140 kips. Now, that all being said, that's fine. That's just how quick and easy it is to calculate the tributary load. So what do we do here? If I want to start designing my columns for those tributary loads, there's a few things that we would need to set up to do that. So for example, one thing that we'll need to do is look at design groups. So typically when you're designing columns, you're going to group them by similarity as far as placement in the structure. So if I'm looking at this particular structure here, I want to group these bottom 4 levels of columns together for design, and I want to group these top 3 levels together for design. Just for simplicity's sake, I'm going to turn off the display of everything except for the columns. And let's go ahead and assign some design groups here. So just windowing these upper columns, I'm going to assign these to new automatically grouped design groups. And then I can simply open a design group and see what we've just generated. So in this section type manager, I see now 3 sections have been defined: 22 by 22, 40 by 22, and 12 by 18. So what does each of these sections mean? It's not only the outer geometry of the column section, but it also tells you what the cover is, the reinforcement percentage. In this case, we haven't run any design, so there's no information in the design status, but we can also see what our vertical bars are. So for example, maybe we want to go to number 8 and maybe 3 face bars per side, and that's going to get us up to 1.3% reinforcement of our section, tie, size, and spacing, and so on. So there's a lot that you can define as far as the actual section, but for the purpose of our demo today, I'm just going to leave the other ones as they are, and I simply want to rename them. I'm going to add a tag to say that these are the upper columns, so that when we auto-assign the columns for the lower section, we know that we won't overwrite anything. Okay, so now I have my 3 upper column design groups, and now I'm going to do the same thing. I'm going to window my lower 4 levels and quickly assign those to be new design groups. Again, auto-assign new grouping and say OK. So again, just quickly going into our design group manager, I can now see these ones that don't have a tag at the end, so I know by default that these are the lower columns. So obviously, if you had a much larger building, maybe you would have a group that would be, level 1 through 4, and then level 5 through 8, and so on and so forth, as you just name these to keep track of everything. Now, beyond this, the next step that you probably want to talk about is live load reduction. That's something that always comes up in the conversation. So there's 2 components of live load reduction. First is that we have to establish which loads are being reduced, and then by how much they're being reduced. So when you go into the load case library, it's important that you establish what loads are reducible. So in this case, I only have dead and live load in the model, so I'm going to indicate that the live load is reducible. That's going to put a little R in parentheses. So any other gravity load cases that you define in your model, you could indicate that those are also reducible. Here, it's not limited to only what's called live load. That's just what I'm doing for our example. Beyond that, you also need to specify the equation by which your live load reduction will take place. So I'm going to just add something kind of simple. Let's say we're going to have, for 150 square foot of area supported, we're going to be at, we're going to be at a factor of 0.88. And for 750 square feet, we're going to be at 0.4. And this will interpolate values in between, or you can just step the values depending on how you want to set up your equation here. So that's it as far as live load reduction. So now, what do we want to do? This is bringing up the same screen that I showed in our opening intro PowerPoint. So I want to run a column design. I'm going to select, at this point of this particular model, I've only done a tributary analysis, so I'm going to use the tributary loads to start designing my columns. I'm not going to go into too much detail here just as out of the constraint of time, but I want to show you some of the design options that you have. So you will be able to automatically iterate the number of designs here up to 25 or whatever you choose. You can specify a ratio of the dimensions of your column, the percentage reinforcement that you'd like to be within, and then increments of spacing and so on. And then primarily these sections become really important, the freezing options. So freezing dimension A and B means your column size dimensions A and B Do you want to freeze them, which means it's going to hold them steady, or do you allow those to be optimized, in which case the dimension can increase or decrease to a certain amount and in certain increments, which you can control here. You can do the same thing with vertical and horizontal bar sizes, and splices on your columns. So just for sake of simplicity, I'm going to keep everything frozen on our call here today. The next step is to actually go ahead and design, and we'll start by designing the design groups. So we have these 6 design groups in this particular project here, and so when I say okay and start designing this, what's happening right now in the background is the program is talking to another software solution called S-Concrete. So when I have run S-Concrete, and that just kind of for the sake of time, I have run a number of models in advance just so that we're not waiting on things to process. So S-Concrete has just been accessed by the software in the background. You notice that it never launched the software. It never even came up and told you that the software was being utilized. But because I have both, I'm able to run this integration. So what I'm seeing here is a design summary for each column section, right? And it's showing me some text in red, some in black. Text in red is indicating where there's been a change. So I'm seeing here that we've increased, several of these designs from, whatever the default was with a utilization of 0, and it's increased to some minimum value. In this case, 1% reinforcement is controlling. I can click to view a report here, which will bring up some really nice HTML report that gives you, a design status with all sorts of information. So this is something that you can access from anywhere as long as you have an internet connection. Now let's go ahead and just select all of these and apply those changes. The next step is to actually go ahead and design each of the individual columns, doing a code check on all of the columns. Now this process takes a little bit longer because it actually has to take the forces for each individual column section in its location and run a design based off of the design group that we just completed. So because this is just slightly more time intensive, I've also run this. So let me pull up my model where we've done that. And here we are. So looking at our model with just the columns shown, we can now review a number of different results. So again, this is just a tributary load design only. So I have both individual column design results and design group results that we can review. So for example, we can review status. Let me just shift where things are located on screen here. So we can look at the status. So we're seeing whether things have been checked, whether they're acceptable, there's a warning or borderline, or they are unacceptable. So we're seeing a number of columns here that are failing. We can look at what our PM interaction is. So here we're going up to 1.16 for our PM utilization. We can see what the reinforcement is and so on. Now this is for the design group, but let's now see how does this apply from an individual standpoint, because obviously the worst case is controlling in the group, but in the individual design you can see here that only some columns are really driving that design as you would expect. So you can see, for example, in this column stack here, we're pretty lightly using this column. We have an interaction of 1.13, and it increases as it goes down, 0.27, 0.4, 0.52. You can see the color gradient changing along the way, 0.89, 1.16. So this is saying, just based on the tributary loads only, we're having an axial capacity failure on these columns. So knowing this, I'm going to say for certain that I'm going to need to change something about those column sections. So one way that I can start to optimize this, we have a really great feature where you can select the columns by their design group and by their usage. So I'm just, let's see if it's, hold on just 1 second. Let me see what this column is. This is a 22 by 22 column. So I can select my column by their design group and by their utilization. So for example, I want to select everything that's above, let's say 0.9 usage. If I say okay, do you see how just a couple of these columns have been selected? I can now go back into my design group manager. I can create a new 22 by 22 column. Maybe I'm calling this lower heavy, you know, whatever I want to call it. And then I can start changing something about this. You know, I can, or maybe I want to call this 24, or maybe I want to change the bars. Instead of being number 5s, I want to change these to number 9s. Right, so you have a lot of things that you can do, probably not this many. Let me back that up a little bit. Something like this. So, you know, you can basically start rerunning this, and you see here, assign to 2 selected components, 1 new design group. So because I have those 2 column sections, I can now assign them to this new group, and then I could just simply rerun my design of that new design group, and then do a code check on that one, and start closing the loop on my design here. Now, in this case, we've only done a tributary analysis, so let's switch to a point where I've done a full finite element analysis. So what that means is I've run the full building with a, in this case, only gravity loads, because that's all that I've applied. And now I want to say, okay, so what happens when I change it? So in this case, you can see the design summary on the design groups going significantly changing, all of the text here in red showing you when something has changed based on the new run that we've done. So going, let me show you what I did. So I switched to an envelope. Okay, so instead of doing just FEM, I switched to an envelope of the 2, and this is showing some significant changes that the program is suggesting. If I select those and apply, that's going to apply all of those changes. Again, I'll want to do FEM and do a code check. So now I've done the design groups, I want to do a code check. And again, just cycling through my models here that I've done. So now I'm at a point where I've done my code check on all of the individual columns with the FEM and a tributary solution in place. And you can see now I have my interaction for my PM interaction on all of my columns here. I'm arranging up to 1.94. So I'm seeing that some of these columns, obviously the ones in red, this is where I'm really getting hammered, and need to go back and obviously make some changes to this particular design to get it to an acceptable range underneath interaction of 1. So in this whole process, I'm able to control and manage all of the design information directly within Adapt Builder. I have not yet, even though I've done several things behind the scenes just to kind of speed up the process for our demonstration, I have not had to open S-Concrete at any point. However, I can very easily do that. So for example, I'm just going to select, you know, some column here. I can right-click and simply open in S-Concrete. So I can launch that particular section for its design right in S-Concrete. So what's happening is just by doing that, this is launching S-Concrete for me, and will bring up this specific column section that I happen to select. So here it's showing me the cross section with all of the reinforcing, some key design checks. I can also pull up my PM interaction and see, in this case, that we're okay. So, you know, you can start kind of sharpening the pencil and getting a lot deeper into your design if you wanted to, by coming right into the S-Concrete software. So what's being used, you know, aside from what we've done here, you know, things that come into play on a project like this, I want to talk for just a moment about the unbraced length. So let me show my full model. So in this particular model, I have predominantly single height columns, but I do have over here, I hope you can see it, I have this notch out and a few slabs, and I have a 3-story height unbraced column. Okay, so does the program take that into account? So for example, let me just select any individual single floor column here. If I calculate the unbraced length, the individual braced length is calculating it correctly for a single floor height, 11 1/4 feet. But if I rotate, or I see that it's one of these columns back here, I can just switch to a single level view, which will make this a little bit easier to see. But if I select one of these columns and look at the unbraced length, you see that it's calculating it here, 33.75 feet. So without me having to specify that to the software, it is smart enough to know where your unbraced length factor is and what the length is to consider in the design. Further, what kind of information do we now take from this, right? We've seen all of these pretty pictures. You know, how can we now extract this information and start getting it into our drawings? One of the things that you can do is export this directly to Excel. Let's just open on my other screen here. So here we can see the column size. So for each floor-to-floor height, you can see the material properties and what the column size is going up its length, what the reinforcement of each column is, the details, meaning how many layers the reinforcement's in, what the design load is in kips, and what the reinforcement percentage is. So obviously here we're at 6.9%, obviously need to come back and do some work on that particular design here. So this is a really nice table that you can start getting your columns scheduled. Additionally, let's say you just want to look in plan and see, what kind of loading and what your axial capacity is. So to do that, I'm just going to hide these upper level columns, look in plan, and let's say, I want to review my individual column results in plan for any given level. So I can display my PM utilization, the design load, and the axial capacity. So if I were to, let's say, scroll down the structure, can you see how the color coding has stuck with it? So I can see, over here, oops, I've lost my my hidden columns. I'm just getting some text over the top of it. So here I can see for this particular column, the PM utilization 0.19, the axial load 363 kips, whereas my axial capacity is 1900 kips, right? Similarly, over here we can see all of the design information for something that's a little bit more heavily loaded. So with that, I'll also show you, in going back to an isometric view, we can change the way that this information is being displayed. In fact, let me go back to a full structure view, and again, just turn off everything but the columns. So here we can see the results. Right now I'm displaying the results based on value, but if I change it to status, for example, we can see if it changes from status to pass-fail. So we can see now, instead of viewing the result gradiating from 0 to whatever the highest value is, we can also switch it to just pass-fail view, so we can more quickly identify which columns are in trouble, or where do we need to sharpen the pencil on our design. With that, I see I have 1 minute left. I'm going to stop myself. I think I've completed the full workflow that I wanted to show you here. So please let me know if you have any questions or comments. Feel free to email me, or if you're a current client, you can always contact our support group, and or use the chat or question feature directly here in GoToWebinar to let me know if there's anything that I can follow up with you. So thank you again for your time today. I hope this was informative, and have a wonderful rest of your day.